Okay, let's start. Today we'll be doing question 3 on Leetcode. Let me put it in the chat. There was some people previously who asked for the question. They wanted to solve it on their own. So I think I'll just start posting it in the chat as a comment for anyone who wants to solve it. Okay, I was just checking my mic. Let's see. The mic is too loud. We'll drop it a bit. I think the music's a little loud too. I'll have to double check this throughout the stream. I think something like this should be fine. Okay, so what is the question? So given a string S, find the length of the longest substring without duplicate characters. And then let's look at the example. We have input S, string characters. The output is 3. Okay, so we don't really care about what the character is. We just want to know the length of the longest character, of the character that has the longest sequence. The title does say longest substring without repeating characters. Okay, what's the explanation? So the answer is ABC, the length of 3. Note that BCA and the AB are also correct answers. Interesting. Okay, wait. Example 2. There is just a string with the letter B. Repeated. What is that? 6 times? I can't really see. 5. Okay. The output is 1. Okay, so it's not how many times does a single character repeat. This next one. Okay, the output is 3. Yeah, this on here. A better idea. I just put the question in the chat, so if anyone wants to solve that when they come in. Okay, the output is 3. The answer is WKE, length of 3. Notice that the answer must be a substring. PWKE is a substring and not a it's a subsequence and not a substring. I don't think I quite understand the examples. Example 1 makes sense to me, so ABC, they're in the correct order, it's one after another, but they're also suggesting that they could be out of order and it will still count. Okay, I'm gonna whiteboard this. And I'll take the examples. Let's see. So the input is a string. And we're outputting what specifically? It's an integer that represents what? The length of the longest substring without duplicate characters. And then how does sliding window fall into the picture? Okay. I don't quite get the question. When they're in order, it makes sense. But then it also says that, so this one's valid, but then it also says that this other one is valid. And we could even have, we have BCA. There's also this one here. I'm wondering, I think I need a hint. Okay, before I look at it, this is what I'm thinking. So, adding window. The first pointer is looking at A. So that means anything that follows has to be, I don't think, wait a minute, what was the third example? What is the time complexity? Okay, this one doesn't give us time complexities there. Wait, I'm confused by the difference of the difference in wording here. So subsequence and substring. I think that wording is throwing me off. Let me get a clarification on that. a substring means a contiguous section of the string. For every possible substring generated, check if it contains duplicates. Track the longest. Okay, chat gave me the same kind of wording as the Leetcode question, so it didn't really help. See if we could simplify it. There's no repeating letters. Why can they be out of order is what I don't understand. Weird constraint. Okay, let me look at the question again. I think I get it. Find the length of the longest substring without duplicates. Let's write a plan. So first, we'll make a left pointer. We'll do it on the same side. Okay, what else? Wait, this is breaking my head. What's with this thing? Getting distracted here. Let's see. Back to this part. Okay, we'll have a pointer like this. We'll compare them. So in this scenario, they're not equal. Can I group them? Okay. Okay. The 2 pointers are not equal, so I can move the right pointer. Okay, in this case, they're also not equal. Or are we doing like, does the right pointer have like a sub check to its left? Would you have to put them in order? No, I think if you sort it, it'll defeat the purpose. Would it? I think it would. Okay. So, yeah, let's assume we're not doing nothing with the left pointer just yet. But we'll start like this. One pointer right next to each other. And then we'll check the right pointer and compare to the value before it. But instead of using the left pointer, we'll just do like the current pointer minus 1. I think you could index a string. So yeah, and then if they're not equal, then we'll increment the right pointer. We'll do the same check to see if the previous value is equal to our current value. And as we're incrementing the right pointer, we're incrementing, essentially, we'll have a counter. Okay, so here it's 1 because A and B are not equal. So we'll have Okay, so yeah, and then we'll move the right pointer, and the counter increments. So as long as they're not equal, we could increment. Okay, so we're at 2, we'll increment. The weird part here is that the duplicate does not exist in the character before it, but at the character in the left pointer. The thing that I don't understand is, like, let's say if we had A, B, C, D, C, say, and we did the same thing. Okay, I think for this example that I wrote out, it wouldn't catch this C, I think, because the left pointer won't be pointing to it. So, okay, you start here, left, the right pointer. You compare it to one index before it. They're not equal, so you move up by 1. Your counter increments are not equal, so we can move the right pointer up by 1. Again, we can move the pointer up by 1. Here, technically we can move it up by 1, if just based on this condition that the current value C is not equal to the index prior to it. That's the only condition in which I was moving the right pointer, because they were not equal. So that check helps when the duplicates exist next to each other, but it doesn't help when the duplicates exist like in between the substring that we've already cleared. So for example here, the condition passes, but technically it shouldn't pass because the C is duplicate. It's a duplicate. So how do we check when a duplicate exists within the substring that we have? I'm not quite sure. I think one of the topic lists was like a hash map or something. How would that help? I'm confused how the sliding window solves this. Okay. What the heck happened to that? Such a headache. Write a table. Okay, we'll use this first example here, and we'll just iterate through the whole thing, and we'll place values, and then we'll think about the conditions in which we update our counter. Okay, so A is not in the map, you can place it. B is not in the map, you can place it. D is not in the map, you can place it. And we get to A, A is in the map. Oh, also as we're placing them in the table, we'll update. So far we've placed 3 values without, we've been able to place the values because there was no duplicate. Okay. Then we're at A now. A has a duplicate. So what we can do is, let's see. Technically, we don't need to remove it. Like if we go like this. Yeah, I don't know. I think I'm spending way too much time on this. Can we continue? So, okay, we've met a duplicate. So what if we continue? We don't update the counter. We'll go to the next value, which is B. Another duplicate. So we don't update the counter. We'll go to the next value, which is C. Another duplicate. Again, go to the next value. B, and then we go B. So the rest of the values are duplicates, but the counter never updates. Does it work with a different set though? Let's try that. What about this one? Okay, so A, not in the set, we can add it. Then we go to B, and we're also incrementing the counter. Then we go to C, then we go to D, then we get to C, and we finish for the longest score. Does it work with some of these other examples here? Like this one. Let's see. So we have P because it's not in the set. It's our count. Cannot spell. Okay, count is 1. Then we get to W. Count becomes 2. Okay, count becomes 2. I think this is where it breaks. We get to the next W. Don't do anything. The count's still 2. Move to K. Okay, I'm still following the logic from before. So technically we update the count to 3. And we get to E. That's 4. So that's wrong. we get to W, you don't do anything. What if every time we get to a duplicate, we clear the table? That. Let's try again. Yeah, let's try that. So B counts 1, W counts 2, then we get to W and we clear the table. And we'll clear, oh, what if we do this? Like max. We'll clear the count. We'll save the maximum substring we found so far. And now we're at the duplicate, that's why we cleared it. We go to the next one, K. Not in the table. Count becomes 1. E. And W. Look at that. Okay, now the question is, does it work with the other one? So I'm gonna look at this one up here. Do the same thing. So make a new table here. Technically, I don't think I need the value. It has, okay, we'll just keep it like this. So okay. So A. A, we save 3 as a max count. A is a duplicate in the table, so we cleared the table. We clear our count. We already copied the maximum. We go to the next value, B. The next value, B. Not in the table, it's B. We do C. Not on the table, but that's 1 and then 2. Then we do B again, and then we only update max if count's greater. In our case, it's not, so we'll still clear this. We'll start again. We have B. Count becomes 1. Okay, it might work with the table. It's not the sliding window though. Just like, I don't understand why. Okay, let's write some pseudocode. There's gotta be like some flaw here too. Okay, what's the plan? Let's write the plan on this. So, make a table. Or a map, I think. Hold non-duplicate values. Okay, what's the next part? Oh, right. Well, variable to hold max subsequence, substring. String. Then we have another variable. Hold current substring length. Okay, what else? Also, where does the loop happen? Does it happen? Does it happen before this or after this? Let's just add the next line. So iterate over string s. Yeah, we'll just keep it as that. We'll check if current character exists in the map. We'll place the character in the map. If it doesn't, then we increment the current count. Okay, what else? Okay, otherwise, the character does exist. We clear the current count. Oh wait, before we clear the current count. Wait, we'll clear the map, not the current count. And then we check if current count is greater than max count. If so, then we update max count. Otherwise, we do nothing with max count. Okay, and then I think we just return max count. Yeah, I'm just gonna name it that too. Okay, let's start up here. Well, actually, let's do a little research here. I think we need a map, but I could be wrong. So my first question, I can't remember. Can a map contain duplicates? Duplicate keys. I think the answer is no. I don't remember. And also, I think it's unordered set. Unordered map. I want to know what other data structure does the same thing but doesn't require a value. Because I could do without the value. Kind of irrelevant here. Unordered set. Stores unique keys only. Cool. Okay, so we're going to use unordered set. We'll take this one. Look at the documentation for unordered set. Here we go. We have to include something. Yes. I'm gonna call it unique map. Okay, what else? Oh, we're gonna call this one max count. Let's iterate over here. So I think we have to index it. And all of this goes inside. Okay, what else? I think current count gets defined outside. Let's see, what else? So check if the current character exists in the map. Yeah, we might have to go back to the documentation. Find, I think I have to use find. Because I'm in an older version. I think we just have to say, let's see, something with end. Yeah. If no such element is found past the end iterator. think we're doing s dot find I think this looks at our current value. So if we think of it in terms of the original string, the first value that it's checking is the first character in the string. Yeah. And then if it exists, it'll be true. Otherwise, we just have to say as long as it's not equal to end. S stuff. I'm missing here. Check. Probably an example here. Okay, what am I missing here then? Wow, okay. We could use the same thing like the example code, which is like search is equal to okay, wait, let me check what the error is. What is yes? Okay. What's the example? Okay. Temporary type? What are you talking about? Okay, what am I missing? Let's look it up, I guess. What if I did? Okay, let's. Where would it go? Invalid operates. What are you talking about? Wait, maybe we do. Wait, why is the time complexity log n? What's time complexity for? I thought it's supposed to be constant. What? Okay, let's see. What do we do? Maps. I guess we'll use map. Not too sure. Wait, what he meant. Where's the other one at? What am I doing? Okay, I know the issue. S is not a map. Maybe I need a break. Let's see. Like that. Magic. So what now? Okay. Okay, it says check if the current character exists in the map, place the character in the map. If it doesn't, and increment the current count. It's right underneath that. So if it's not in the map, say current count plus, and then we do, is it append? I think that's something else. That's what again? What's next? Okay, if it is in a map, we'll do else. Otherwise, the char does not exist and you clear the map. Okay, we can clear the map. How do we clear a map? Empty? No. It's right here, clear. Yeah, I think I'm almost to the finish line. So, otherwise, it's in the map. We can clear the map. We can say neat map. Okay. We do have to do a check, which says if the current count is greater than max count, we update the max count variable. We say if current count is greater than max count. Max count. Okay, we just update max count. Also, is it size minus 1? It might be size minus 1. Can we test this? Okay. Just through 0, okay. Oh, wait. I think we do one last thing at the end. So let's assume there was no duplicates. We would want to place the current count. We would want to update max count to be equal to the current count. So, that's not what I meant. I don't know why I answered. might fail for a different reason. Okay, let's see. Okay, still 0. Wait a minute. Yeah, this. It's supposed to go out here, not in there. Nice. Didn't work. Okay. Yeah, let's debug this. What is the question? I'm not gonna write that out. Okay, what is the example? So is it not that? What am I missing here? Oh, I see. Oh, I can't remember which one it was. I think it was this one. Okay. What is this? Okay, they should still print 0. Verify that. Yeah, okay. Oh wait, I should add G flag. Okay, now let's try to debug. Oh. Breakpoint there. Then we'll do printing 0. Oh, I skipped it. Okay, let's try again. Yeah. Okay. Step into. Okay. Max count 0. It should be 3, I believe. So, okay, current count 0. So we're gonna iterate over the string. What is this value here? What is search? Search should be A. Thing's long. Wait. What is A? It is A. Okay. Sorry. What is search? Search is A. I don't know why it doesn't wrap. Okay. Anyways, so it should not be in the map. So it should jump to. It should jump to the else. And the else clears the map. I should check if it's empty. I think it's empty. Let's look at this. Okay, that is a valid thing. Can we try to run that? Okay, still 0. That's okay. Okay, let's just go with A. I think I'm just typing stuff at this point. I should not do that. Let's see. Do this again. So the first value won't be in the map. Okay, the logic is flawed here. Wait, why does it skip? Wait, I think this first one is checking if it is in the map. If it's not in the map, it should equal to end. find returns end, that means the value search is not in the map. So we should place it in the map and increment count. Otherwise, the find method returned end, which means that the value was in the map. Sorry. I don't know if I did that already. Okay, at least it's counting. Let's figure out why it's overcounting. Still A. A is not in the map, so count becomes 1. Okay, wait. I think I need a break. Put a timer on. did I leave off? Okay, why was it printing 6? I think that's what we're trying to figure out. I think it's over counting. The answer should be 3. Why could it possibly overcount? Let's see. When it sees a duplicate, we are not resetting count. Here. So we update max count and then we say current count equal to 0. Okay, let's stop this. Let's add some more test cases. B. We changed this to example 3. Is that the expected? It is. Okay. I think that was it. Let's go back up. Take this. We'll close this. Wait, here was. Okay. Just paste it on here. As to the test cases, we knew that. So we shouldn't jump forward. We should clear, but then place the current value. So we'll clear, but we'll place. So this else statement just is the part where we found a duplicate in the map, but we want to clear the map, but we want to insert back the current value since we're counting from this current value forward. Alright, again, we'll submit because the tests passed previously. Oh well, actually let me see, let's do the other test still pass. to assume that they'll pass. Wait, what is it throwing away? I'm confused. It's definitely breaking from the loop. So we update the max, which was 2. W gets put in the max. Oh, I think we don't set it. We set it to 1. Let's see what it says. Okay, it's just gonna give me the sliding window solution as if I asked about that. Nice. Okay. You just spent like 40 minutes on the wrong solution. It's cool. I just didn't understand how the left and right pointer would solve this, which was like, what I didn't understand about the left and right pointer was, how does it catch the substrings within the current valid string? For example, if the string was this dvdf, when we got to D, we could look one back to see that it's not a duplicate with the previous value. We could look at the left pointer, we'll find the duplicate. But if there was more values in between here, how would we know that there was not a duplicate there as well? Not clicking. Oh wait, we can watch. Let's watch this. Turn the music down.
Code 3, longest substring without repeating characters. We're back to a classic Leetcode problem, the third one. So this one's pretty simple. We're just given a string and we want to find the longest substring without any repeating characters, right? Like how these three don't have any duplicate characters, A, B, C. This one has two A's, so this would not count as a substring without repeating characters. And we only need to return the length of this substring. So the first idea that comes to my mind at least is, so just check every single substring, check if it has any duplicates. If it doesn't, then we're just going to take the longest one of those strings and return the length. So how would that algorithm run? Okay, first we'd start at A. We want to get every substring starting at A. So just this one A, well, that doesn't have any duplicates. AB, that doesn't have any duplicates. AC, that doesn't have any duplicates either. And then we get to this first duplicate A. We have two A's now, but remember, we're checking every single substring starting at this first A. So we're going to keep this algorithm going, even though we don't have to. Every substring we get after that, like, see how we're doing it? Every single substring after is also going to have duplicates. So do we even need to check all of these starting at value A? This is the repeated work that we're going to eliminate with our very fundamental technique, the sliding window. So we want to only check substrings without any repeated characters. So let's actually just do that. Let's make sure that our window, right, our subarray, our substring is always not containing any duplicates. So once we get to this next A, we're going to say, well, now we have two A's. So we need to start removing from the left. We need to start shrinking our sliding window until we no longer have duplicates. So I'm going to say remove this one from our substring. Now our substring runs from here, from the B, all the way to the A. Now it's perfectly valid, so now we can keep going. It's still only length 3 though, so next we're going to add this B. But wait a minute, now we have 2 B's. But my question is, how would we even know instantly whether we had a duplicate or not? Well, we can use a set for that. Sets will only contain one of each character, so we'll automatically know if we have a duplicate. We can check it instantly. So we're going to check that we have 2 B's, so now we're going to keep popping from the left. We're going to keep shrinking our window from the left until we remove a B. And we're going to see that the first one we remove is the B, so now we're done. So now our substring runs from this C all the way to this B. Now we're going to add another character. Once again, we have a duplicate. And once again, we can literally just remove the farthest left character, and now we're valid again. No more duplicates. We're running all the way from A to C. Next, we add a B. The interesting thing about this is that now we have to remove this A because we have to shrink our window. Our substring has to be contiguous, so we have to remove this A. But notice we still have 2 B's in our substring, so we got to remove another character. We have to remove this B. So now our substring runs from C to B. So we are valid again, but now our substring is only length 2. Next, we'll get to the last B, last character we're adding, and see, yep, it's a duplicate again. And don't forget that as we're removing these characters from the left, we're removing a C. We're not just removing it from our window, but we also have to remove it from our set, because our set is going to correspond to all the characters inside of our substring that we're at. So we have to remove our C from the window and move it from the set. We have to take this B and do the same thing. And now we have no more characters to add. With this sliding window technique, which is a very fundamental technique that you'll probably see a lot more in a lot of different problems, we can cut the time complexity down to big O of n. We just have to go through the entire list. We might have to add and remove values from our set, but that's a very quick operation. The memory complexity, because of our set, is also going to be big O of n, because potentially every character in the string could be unique, and we'll add all of them to our set. And I didn't really show it while we were going through the problem, but we would want to maintain what's the longest substring we found. In our case, it was obvious that the longest we found was of length 3. So remember, the first thing we need to do is get a set to make sure we have all the characters in our window. So I'll call it character set. And we're going to do a sliding window, so we need 2 pointers, a left pointer and a right pointer, to determine our sliding window. Our left will be initialized to 0, and our right pointer is going to continuously be changing as we visit every character. So I can just use it in this for loop. So the right pointer is going to go through every single character. Now remember, if we get to a duplicate character, that means we have to update our window and our set. So while this character that we just visit at the right pointer, S of R, is already inside our character set, meaning it's a duplicate, then we got to update our window. So we have to take the left character and remove it from our set. So character set dot remove the leftmost character, and then of course we have to update that left pointer, increment it by 1. And we're going to keep doing this while that duplicate remains in the character set. After we've removed all duplicates, then we can just add this rightmost character to our set. And since at this point we know for sure that our substring doesn't have any duplicates, we can potentially update our result variable, which I never declared, so let me declare it up here. Result is initially going to be 0. And now we can update our result, so we can potentially make it larger than it is if the current window size is greater than what it is right now, which we can compute by right minus left plus 1. And then at the end, once we've gone through the entire string, we can return the result. If this was helpful, leave a like and subscribe, and thank you for watching.
Wait, does a set allow duplicates? I'm confused how he's using the while loop. Because it's saying while SR is in the set, we want to remove it, then increment the left pointer. Okay, I'm not gonna solve it on here. I'm gonna leave my old solution since I just looked at their solution. I'm gonna have to come back to this one. I'll leave it as unsolved. Yeah, I think I'll leave it like that. But I think that's also it for today. Not my best, but I've also had like a week off, so doesn't help. But I'll try to be more consistent. I'm also doing the code path thing, and we haven't started doing Leetcode yet, but they're teaching us Python. And eventually I want to change from C++ to Python. Might make it a lot easier to solve these problems. I kind of always have like syntax issues, so it's really annoying. But I think for today,